Hi, I am Kasten, and today I'm going to show you a real-life application of finding the incenter of a triangle. First of all, we do not need this algebra window, so we could hit the X up in the corner. And to get rid of these axes right here, or the coordinate grid, we could hit this button right up here. And the problem is a farmer wants us to find the incenter of his triangular cornfield so he knows where to start his center pivot irrigation system. So first of all, we need to input our picture. And in order to import our picture, we go from the third button from the right and hit the down arrow. We scroll through that list and find our insert image. Once you find our insert image, we click anywhere on to pull up our files, and then you are going to want to select the picture that you named it as. And I'm selecting Cornfield Project Picture for my picture. And then you hit open. Now you could move the sheet of paper from the last button. You could move the sheet of paper anywhere you want it to by clicking on the last button. Next, you could also move just the picture using the first button, the move tool. There. Next, since I couldn't find a triangular cornfield, I am just going to crop a triangular cornfield out of this cornfield. First of all, we need to click on the second button in from the left, new point. Once we click that, we could crop out our triangle that we want for our triangular cornfield. You could also right click on the points, go to object properties. You could change the name of the point, you could change the definition of the point, and you could caption the point. You could also change the color of the point, and you could change the point size and the point style. After we get that, we're going to want to move point B's letter with the move tool, the first button, because it's going to be in the way of our segments. After that, we are going to want to connect the points in order to make our triangle. And in order to make our triangle, we go to the third button in, hit the down arrow, and select segment between 2 points. And the key trick to this is you have to select the point and select the other point where you want the segment to be. After that, after you get the whole triangle made with the segment, this is also changing the redefine or moving your points. We don't need that right now. You click on the point and go to the next point. Now, if I haven't told you already, I'm kind of slow. We're doing this in a step-by-step formation. Next, after we get our triangle made, our triangular cornfield, he wants us to find the incenter. And in order to find the incenter, we need to go to the fourth button in and down arrow it and scroll through the list until we find angle bisector to bisect each angle congruently. And another trick is the angle you want to bisect is the second letter you click on. So if I want to bisect angle A, I am going to hit B first, then A for my second angle, and then C. Now angle A is bisected. Now if I want to bisect angle C, I can hit B, C, A, or I could also go ACB. After you get each of the angles bisected, the point of concurrency is the point where each line intersects, and the point of concurrency theorem states that the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangle. So in other words, from this side of the triangle to here, it is the same distance as from here to there and from here to there. So this is the incenter. Once I've bisected each angle, I'm going to hit new point to add a new point, which is the second button in from the left, and I'm going to go down here and make sure all 3 lines grow thicker and more dark. If they grow thicker and more dark, that means you're on every single line. You could click and add a new point. I'm going to right click on this point D, which is the intersection of point D and E, and I'm going to object properties, and we're going to make this a different color so we can see it. We are also going to make it up to 0.7 size. After that, I exit out and we have our point. That may be a little bit big, so we're going to go down, we're going to hit object properties again. Style, will probably try 5. Let's see how that looks. Exit out of that window. 5 looks like a good amount of number. So D is our in-center of triangle ABC. And now, since D is our in-center, this is where he's going to start his center pivot irrigation. Now, we wanted it to be equidistant from each side so his center pivot irrigation doesn't go off of his field. So next I'm going to inscribe a circle using the 6th button in, down arrow it, and select circle with center through point. Next I'm going to click on point D, go out to one of the sides and click again. There's my inscribed circle. The inscribed circle shows the end of your center pivot irrigation system, so it covers as much of the cornfield as it possibly can without going off of his field and getting the nutrients and water to the corn. Now, to check to see if we did this right, we grab the move tool, which is the first button, and we grab one of the vertices of the triangle, and we now click and drag the vertex to show that the circle stays inscribed. So as you can see, the circle stays inscribed, and we know that we found the in-center of the triangular cornfield. Now, you'd want to do this for a rectangular. If you wanted to do this for a rectangular cornfield, it would be hard to get it inscribed. So you divide the rectangular cornfield diagonally. So you divide it diagonally, and you'd put a center pivot irrigation system in one triangle, and do the same thing for the other triangle to get 2 center pivot irrigation systems for one field. And since we've constructed a triangular cornfield out of a regular cornfield with points A, B, and C, and connected them with the segment between 2 points, command under the 3rd button, then we angle bisected each of the angles using the 4th button in, down arrow, and angle bisected it. And we did that by clicking on the first angle, then the angle we wanted to bisect, then the second angle. After we've bisected each angle, the point of concurrency theorem states that the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangle. So we wanted it to be equidistant from the sides so his center pivot irrigation system didn't go all over the place. After that, the point of concurrency is the in-center, which is equidistant from each side. From there, we went to the 6th button in and selected circle with center through point. We clicked on the in-center, which is point D, and went out to one of the sides to show the end of the center pivot irrigation system, covering as much of the cornfield as he possibly can. Thank you, and I hope you learned a lot from this lesson.